It's great to come your way once again. My name is Nana Yawedu, and you can call me Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all videos on time. In our previous lesson, we have considered the area around the graph. And we mentioned that when we draw a graph, sometimes we can get two-dimensional shape like the triangle, like the square, like the rectangle, like the trapezium. So to find the area around the graph is to find the area of that two-dimensional shape that the graph has formed. So for instance, if you have the shape of a trapezium, you have to use the area of a trapezium, which is half multiplying the sum of the parallel sides multiplying the height. In this lesson, we want to consider parabolic functions. And we want to consider the parabolic functions as functions that are quadratic functions of the form y is equal to as squared plus bs plus c. We'll look at the graph around them, how we can interpret the graph, and how important they are in our real life. Now, let's consider the parabolic function. So when we look at the parabolic function, we are looking at the function that is of the form y is equal to as squared plus bs plus c. Right, so the nature of the coefficient of the s squared determines the type of graph. Right, so we have a graph that looks like the union sign, right, u, that we see here. And in that case, when we move on, we'll look at it and we'll realize that in that case, the a should be greater than 0. And then we have the y that looks like the intersection sign. Right, in that case, you see that the a should be less than 0. And then the points here represents the solution to the parabolic function or the parabolic equation. Right, so to find the solutions, the point that touches the x-axis represents the solution. So here, the points here that touches the x-axis represents the solution. So we say that for the graph of a quadratic function, we can write them as what? Y is equal to as squared plus bs plus c. So for example, you can have y is equal to s squared plus 5x plus 6. This is a quadratic function, which is a parabolic function. We can also have y is equal to negative 3x squared plus 6x plus 1, which is also a parabolic function, right? And the shape can be like the intersection, right? As we said, the intersection symbol. In that case, you see that it is opening downward, right? So it's open downwards. And then it can also be like the union sign, right? Which is here. And in that case, the shape is open upwards. So it's open at the top part, right? So when a is less than 0, or if you have a function which is y is equal to, for instance, negative 3x squared, right, minus 6x minus 1. Once we see the constant, right, or the coefficient of the s square, or the constant that is attached to the s square, which is negative 3, and we know that that a is less than 0, because negative 3 is less than 0, then that graph is shaped like the, right, intersection sign. So it's shaped upward, right? So we have the graph shaped upward, right? So that graph is shaped upward. And it has a maximum point. So the maximum point is the point here, the point where it reaches its apex. So that represents the maximum point, right? And then we see that this part down here is the negative y part. So it increases at the interval from negative infinity. We know this side it could go up to negative infinity. So it increases from negative infinity to the point of the maximum here, which we can call u, right? And then whilst it is decreasing, it will decrease from u here down, right, to positive infinity here. So it will decrease from that side. So it will be decreasing up to the infinity on the positive side, right, which is on this side, the positive side here. So that is when it decreases. And it has a range y, which is equal to negative infinity, right, to u inclusive, right? So this means that u is inclusive. And then we can also have the a being greater than 0. So for instance, we can have y to be equal to 6x squared minus 2x plus 1. We are only interested in the coefficient of the x square, or the constant that is attached to the x square. So once it is 6, we know that a is greater than 0, or a, which is 6, is greater than 0, right? And in that case, we see that that shape is like the union sign, so it's curved downward, right? It's curved downward. So it has the solutions here and here. It also has a minimum point. So this side is a minimum point. Where it reaches its apex, it's called a minimum point, right? So it has a minimum point. And in this case, you realize that it decreases in the interval of negative infinity to u. So we see that from here, at the negative side of the x, it begins to decrease, right? Begins to decrease up to the u. So it decreases up to we get to the u here, right? And then it increases from u to positive infinity. So it increases from this side to positive infinity. And it has a range y is equal to, right, u inclusive to the positive infinity sign. So in this lesson, basically, we have looked at the parabolic or the quadratic function. And we mentioned that for parabolic or quadratic functions, depending on the coefficient of the s square, you can have the shape increasing or the shape decreasing, or the shape being in the form of the intersection sign, or in the form of the union sign, or in the form of more of a valley, or in the form of a mountain. In our next lesson, we want to consider how we can graph parabolic function. Remember to like this video, share this video, and subscribe to my YouTube channel. See you soon.